Hello everyone. Today we are going to talk about how to solve these differential equations. Here are our boundary conditions. So first of all, we can move this term to the right hand side to both sides divided by the first derivative of y with respect to the x, and at the both sides we integrate them with respect to the x. And here we are. And the next step is to integrate the both sides from 0 to x with, of course, with respect to x. And here is the next step. As we know, when x equals 0, y equals 1 from the boundary conditions. So we can solve this one. But here is our question. So from here we can see clearly we need to solve what's a. So by combining with the boundary condition, we can solve a. So we put x equals infinity to this function, and we got this one. This one is we can see it. We can clearly, of course, this one is not an elementary function. So we need, but this integral is very important when in terms of the mathematics. And we can get solve the integral of this function by assuming f equals this function. And of course we can change the variable from x to y, and by doing this we didn't change the value, so f also equals this function. And by times this function with this function, we can get f squared equals 1 times 2. So here we can see we need to change the Cartesian coordinates to polar coordinates. So basically, as we all know, dx times dy equals dA. dA also mean dA means an area. And by assuming r squared equals x squared plus y squared, we can get this function. And by doing this, we can change this function from Cartesian coordinates to polar coordinates. And by doing that, we can get an elementary function. I mean, from here, the antiderivative antiderivative is not an elementary function, but here we can see we got another variable times the previous antiderivative. By doing that, we got an elementary function, and this one is very simple. We can get this value by it's very simple, just integrating from here to here, and by doing that we can get the value of f squared equals pi divided by 4, and it's obvious f is positive. It's not negative, as you all know, since as we all know from the graph of this derivative, we gotta know f equals this area. I mean, from this line, this curve to be between this curve and x axis. So f must equals positive square root of pi divided by 2, not negative. So by doing that, we gotta know this integral must equals square root of pi divided by 2, and we gotta know a equals negative 2 divided by square root of pi. And by doing that, we can put a to this function, and we have this function. Basically, here we almost get the very solution of this of y, but because we all know we have a very special function. It's called error function. So by doing that, we can change this function, change this equation to this one. Okay, that's all. Thank you for watching.